Hi guys, okay, so this is going to be my RPE engine build. We've stripped our motor down. This motor is just a 6.5 horsepower Chinese imitation Honda. I have many of them, and that's what we're going to be using. First thing we're going to do is modify the cam so this engine that is a 4-stroke effectively becomes a 2-stroke in this setup. And the reason I've opted for this instead of a standard 2-stroke engine is because we have no exhaust ports or transfer ports in the barrel, which are about 3/4 of the way down, or 60% down the stroke of a 2-stroke engine. This way we can achieve a full power stroke from top to bottom of the cylinder, whereas in a 2-stroke the power stroke, or the power from the stroke, will only be achieved till such time as it hits the exhaust port, which will be roughly about 60% of the standard 4-stroke. The first thing we've got to do is of course modify the camshaft so as we can get the exhaust valve to open every stroke instead of every second, or should I say every cycle or revolution instead of every second revolution. So here we have the camshaft. First thing we're going to do with it is we're going to rip out the auto decompression, because we're not going to use that. And fortunately for us, the duration and lift both on the inlet and the exhaust lobe are identical. The other thing is the leading and trailing duration is also identical. So rather than having to pull another camshaft out of another engine, I'm simply going to cut this lobe off and weld it straight on the back of the exhaust lobe. The other thing with this is, because of the amount of teeth, I can achieve a 7.4 degree adjustment simply by advancing the timing one tooth on the cam, and 7 to 8 degrees is going to be the exact amount we need to advance the exhaust on this so as it works properly. So the exhaust valve is going to actually start opening just before the piston gets to the bottom. If we need any fine adjustments, we can simply do that with the tappets or the rocker arm adjusters. May get a little ticky, but that's not the point, and it's not a problem because this is just a prototype, a proof of concept engine. If this can run for 24 hours by itself, then we can worry about extreme engineering and all that. So that's what we've got to do next. Is we've got to cut the lobe off of the inlet, and we've got to weld it on the backside of the lobe for the exhaust exactly 180 degrees out. And this is quite simple to do, just with some timber, and a drill and maybe a file. But first we're going to go ahead, I'm going to cut this lobe off. Hopefully I'm going to be able to do it with a hacksaw and a fine blade. If not, we'll have to use the grinder and a 1mm disc. So that's first up. Then we're going to build our little wooden box so as we can get this lobe correctly placed on the back of that one, and then we're simply going to weld it in position, hopefully. These are cast steel, so it should weld alright, and hopefully we won't warp the cam too much. We're very careful to let it warm up very slowly. So let's see how we go with it. The other thing I noticed, I did have a bit of rust on the bearing surface area, so I'm going to have to polish that up again, but like I said, if it runs for 24 hours by itself, that'll be good enough to spend some money on it and build something decent of higher quality. But to start with, I'm going to try and do it as cheap as possible, because sometimes we just spend way too much money on projects that don't work. In saying that, looking had all the gas figures, temperatures, expansion rates, pressures, all that. I actually believe that this could possibly work. In fact, I strongly believe it will. Our biggest issue, of course, is going to be heating the gas inside the cylinder and cooling it before it goes back into the tank and turn it back to a liquid. But let's see how we go. This will be a bits and pieces video. I'll just join it all together once I've completed the job and make sure it works. Let's get on with the show. Alrighty, so we managed to cut the lobe off. I did have to use a grinder. This is fairly hard stuff, as we can imagine. It's been heat treated, hardened, and as you can see, we no longer have our lobe on our inlet side. Make sure you cut the right one off. And we've also ground a flat opposite to this, so as our lobe that we're going to weld on will fit straight on there like yay, and we will simply put a little weld in there once it's in the right position, and then we'll go ahead, gouge out the two side joints and also weld in there, and then we'll spend a couple of hours on the file getting it all right. So the next thing we've got to do is make up a little wooden frame that has our lobe shape on it, and then we're simply going to turn the cam 180 degrees, and this will fit in that shape that our lobe was on. So we will then have this lobe in the exact position 180 degrees opposite to the original lobe. And then, like I said, we spend a lot of time on the file and buffer, making it all smooth. And this is not going to do 20,000 hours of run time. We're only building a proof of concept motor, so this will do just fine for that, providing this all welds properly, of course, which we'll find out soon enough. Okay, I'm just going to document this timber jig, just in case anyone else wants to do it. I'm sure you can work it out, but this is how I'm going to do it. 3 bits of timber, in this case it's crappy old chipboard. First we've got to drill a hole same size as the lobe, which in this case is 14mm in one of the bits of timber, and then that will push nice and firmly down into that hole. Our second bit of timber, we're going to drill the same hole, sit the cam in it and trace around the outer gear. We're then going to take a jigsaw and we're going to cut that circle out, because I don't have a hole saw quite big enough. I'm about 2mm too small. Now our third bit of timber, so this one here, what we've got to do with this to start with is we've got to draw a nice straight line through it. Like yay. Doesn't matter where, all that's going to be centralised once we screw all these 3 pieces together. Then what we've got to do is we've got to drill a hole in that so as it fits around here. So we're going to be looking about 18mm. And then what we're going to do is, once we've drilled the hole in this, is we're going to mark all of these once the cam is sitting in place, both on this one and with this one over the top of it. Those 2 boards will be in place, and then we're going to sit this one here, and we're going to mark one side so as we know which all goes where. So I'll go ahead and we'll cut that out, and then we'll drill the hole in this one. I've actually got to cut this one in half so as we can slip the 2 halves around the cam. So what happens then is we mark a line on the lobe here, as close to centre as we can get it. Doesn't really matter if it's off, because it'll be off both 180 degrees out to each other in the same spot. we'll line that mark up with this mark, and we will then fit this lobe here on there. So is that position there on the centre of the lobe is in line with this mark. This will make sure that these two lobes are 180 degrees out for each other. So we could take a guess and just do it by eye, stick it on there, and that would probably be good enough for this experiment, but we'll get as close as we can to start with. So we'll go ahead and we'll do some cutting and drilling. Alright, well, I've already gone and tacked the lobe on there, and this is basically what we want to do. And we have our two dots on the very tip of the lobes lined up with this line, and we can simply turn it 180 degrees and make sure that our two dots once again line up with our straight line. So they're very close, and we'll be able to get it spot on when it comes time for the filing and polishing. So that's how we get them exactly opposite, and like I said, that's pretty close. So I've tacked it one side and the other. I'll go ahead and weld it a little bit more each side, let the heat build up a bit, and then we'll give it a bit more weld. And then we're going to gouge down through here and also weld, fillet weld that as well. The good old MIG welder with the flux core wire seems to do a very good job. It's welding this steel alright, so I don't see any issues there. And it's also fairly hard, so it should work out just nice, hopefully. Alright, so we'll go and fully weld this up, clean it all up, and we'll come back and have a look at it. Here's our camshaft all welded up, as you can see. You'll see I put tape around each journal, and I did have some around the gear as well to stop splatter going on, but I've taken the one off the gear. At the moment it looks very terrible, I know, but give me 20 minutes with a file and the buff and we'll come back and have a look at it. Well, after 15 minutes on the file and the fine grinder, we're pretty much done. A little more polishing up to do, and this will be ready to go into the engine. Our double lobe cam. First I'm going to put it back in the jig, get some measurements, make sure we have the same lift on each side, of course, and durations are correct, and then we'll stick it in the motor and see what happens. Alright, well, I've put the piston and conrod and everything back in the motor. You'll see the timing marks here and here on the crank, and you'll notice I've got it 1 tooth out. I've advanced the timing of the camshaft a little because I want the exhaust to be able to open before the piston gets to the bottom, and this is also so as it closes before it gets to the top and compresses a small amount of gas to get a little extra heat into the cylinder. We can of course advance it a little more should we need a little more heat in the cylinder via compression of the gas. So each tooth is 7.4 degrees advanced, so we'll start off with one. Now we're going to whack the head and everything back on, make sure everything works as it should, and see how our new cam goes. Okay, so we've just thrown the piston back in, side cover back on, we've thrown the head on, we've got rid of the inlet rocker assembly, don't need that, and we have our exhaust one all hooked up. Mark top dead centre there, and also bottom dead centre, and top dead centre you can see our valve is just starting to tighten up, or should I say slacken off, close, which is our top dead centre mark there. So if we go around to our bottom dead centre, now I've designed it, or I've timed it so it starts opening about 7.4 degrees before bottom dead centre. and you can see it is indeed tight there, which means that it starts to open, and it will carry on through till it gets to top, and then it will shut. So we now have our 4-stroke converted to a 2-stroke, and the cam doesn't seem to have warped at all. It is very free spinning. So far so good. The cam seems to work quite fine. Later on we may have to, when it comes to tuning, getting the absolute best performance out of the engine, I may have to knock some of the duration time off of the cam, just so it opens and closes a little more precisely. So we want it to probably be fully closed around 14 degrees maybe before top dead centre, so it's got a small amount of gas in there to compress and heat up. And then of course at the moment it is opening at the correct time, which is just before bottom dead centre to start the gas flow on the exhaust side. But total time to convert that cam, modify that cam, it was about 3 hours work. I've polished it all up, it's nice and smooth, and it works a treat. So this should do the job. I do of course have to strip the motor right down, clean it all up again. It's been sitting around for a while, so, but of course we have our shaft hanging out here, chuck our pulley on to drive our pump or compressor, whatever you want to call it, and I have a fair few more of these motors. This one's had the output shaft chopped off it, the crankshaft, so that'll be good for spare parts. But so far our tricky bit, the cam, is all done and works very well. Cheers guys.